Good morning, friends. I am here again for my course, Flight Mechanics, my favorite course. And as of now, I have completed my 5 lectures in this topic. Before this, I have completed my 3 more courses. First one is Engineering Thermodynamics. Second one is Aircraft Systems. Third one is Aircraft Stability and Control. This is my 4th one, Flight Mechanics. This is taught in Institute of Aeronautical Engineering, Department of Aeronautical Engineering, Hyderabad, for the 4th semester on 2023 from February to June 2023. My topic for the day is Introduction to Atmosphere. This is the topic, and my name is Dr. Yagya Dutta Dwivedhi, and I am from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Also, in this, I will be discussing these topics: International Standard Atmosphere, Types of Atmosphere, Gravity Relationship, Geo-potential altitude, plot of International Standard Atmosphere. This I will be discussing in today's lecture. International Standard Atmosphere. What is this? And that I am going to explain. You know that atmosphere is changing from country to country, from location to location, from one continent to another continent. But how we can say that internationally it is an acceptable atmosphere? Because your aircraft is flying, and during the aircraft it is flying in the atmosphere. So all these parameters, especially the pressure, density and the temperature, is varying at different locations, different altitude. So we should understand, before we go further for discussing about aircraft lift, drag and other aerodynamic parameters, we should first understand what is the International Standard Atmosphere. So that is the objective of this lecture. Before we go for further detailing, we should understand these all topics. It is important to understand various altitudes that are usually used to analyze, compare the performance of flying vehicle at standard atmosphere. The gravitational force experienced by any aircraft varies with the altitude. So as we go up and up, the gravity will also differ. The density is different, so your lift will also be different, your drag will be also different, your thrust also will not be same as it is in the near the sea level. So the gravitational force experienced by an aircraft varies with altitude. An aircraft experiences variation in aerodynamic forces with altitude. Atmospheric properties like pressure, density and the temperature, P, rho and T, also changes with altitude. Aerodynamic forces are a strong function of these atmospheric properties, that is P, rho and T. It is necessity to specify the altitude that will help in postulating gravitational and aerodynamic forces explicitly. So it is very much essential that as per the altitude, our gravitational force means weight, and the aerodynamic forces have to understand at the different level. So we have to see that types of altitude. So how many types of heights are there? So first one is absolute altitude. It is called HA. The altitude as measured from the center of the earth. So if you see this diagram, here HA, it is the center of the earth. Center of the earth. So from here, if your aircraft is here, so if you are measuring from the center of the earth, this is called the absolute altitude. Another is called the geometric altitude, HG. this geometric altitude, the altitude as measured from the mean sea level. So this is the mean sea level. From here, if you are measuring, it is called the sea level, and it is the mean sea level, and this is called Hg. So there is a difference between absolute altitude. This absolute altitude is measured from the center of the earth, but geometric altitude from the surface of the earth, and that surface we say as a sea level measurement. Okay, next one is the geo-potential altitude H. So there is a difference between geometric altitude, understand, and then geo-potential altitude, it is only H. The geo-potential altitude corrected for the gravity variation. So if you correct this with the gravity variation, geometric altitude, this Hg altitude corrected for the gravity variation, we will be discussing this in later. So this we can see here that this absolute altitude, this is the absolute, this altitude is equal to geometric altitude Hg plus R. R is the radius of earth. Radius of earth. So that we have to see it, we have to do it. Now I will discuss about gravity and altitude relationship. So how this gravity will vary as per the variation of the altitude, that we are going to discuss here, because we have seen in the previous that this Hg and H, the altitude measured from the sea level, but this geopotential altitude, it is corrected. It is a geometric altitude corrected from the gravity variation that we will be observing in this slide. It can be obtained using Newton's universal law of gravitation. If gravitational acceleration at the sea level is g naught and the local gravitational constant is g for a given absolute altitude ha. So if there is a g naught at the sea level and the g at the certain your altitude, the gravitational acceleration is g, then ha. Then the relationship between the g and hg follows that g is equal to g naught r by ha whole square. Means r is the radius of the earth and ha is the absolute height. But we have seen in the equation 1 that ha is equal to r plus hg. So this we have replaced from here to here. So this r plus hg whole square. So this is the geopotential and geometrical altitudes. What is the difference between geopotential and geometric altitude? The hydrostatic equation of an infinitesimal fluid is given by dp is equal to minus rho g dhg, where p is a pressure, rho is a density in kg per meter cube, g is acceleration due to gravity in meter per second square, corresponding to the geometric altitude hg, where hg is a geometric altitude. To obtain this pressure P, the above equation to be integrated, where rho and g are the function of h, makes integration complex. So, to make integration simple, geopotential height h has been introduced. So, to make this thing hg, we will now use the geopotential height. So, what is the geopotential altitude h? It can be called as the gravity adjusted height. So, geopotential height or altitude h is a height, gravity adjusted height. The adjustment uses earth mean sea level as a reference. Rewriting the hydrostatic equation by replacing the geometric altitude with geopotential altitude h. So, we can write here dp is equal to minus rho g naught dh. We have replaced by this thing where g naught is the acceleration due to gravity at mean sea level. Using equation 3 and 4, we can derive the relationship between geometric and geopotential altitude. Means geometric is hg and geopotential altitude is h. So we will find out the relation between this by using the equation number 3 and 4. So if we divide both 3 and 4, so here we will get 1, here we will get g naught by g, and here dh by dhg, because rho is constant, so rho is gone. So here we can see that dh is equal to g by g naught dhg. So this dh is equal to g by g naught. This g by g naught is varying by r plus hg whole square. So r square r plus hg square into dhg. So this is the relation which we have got, that the geopotential height h is equal to r square by r plus hg whole square plus dhg. So we can see that integrating dh from sea level up to the any given value of h that is different from hg at a given point in atmosphere where geometric altitude is hg. So we can get here that if we integrate from 0 to h dh, 0 to hg, r square by r plus hg square hg. So here we can see that 0 to here, 0 to hg, dhg r by hg whole square. Okay, so here we can see that r square here. So this h is equal to r square, and here we will get r plus hg whole square. We will get minus 1 by r hg, 0 to hg, r square minus 1 by r hg plus 1 by r square. So here minus r plus hg, r plus hg minus r plus r. Here r and r. So only one r is left. So r by r plus hg into hg. So we got that geopotential height h is equal to r divided by r plus hg into hg. So this is the relation between geopotential height hg and the h is geopotential, and this is the geometric height. So hg is what here? Geometric height. So the geopotential altitude h is equal to r plus hg into hg. Now we will discuss about the, so we got here the relationship between h is equal to r plus hg into hg, and this, if it is the 65 kilometer, only 1% difference is there between h and hg. So that is not a very much different. Now the definition of the standard atmosphere. So before we proceed for the standard atmosphere, why we require to understand about the standard atmosphere? Because your aircraft is flying and your temperature, pressure and the density of the atmosphere is varying. If we vary this, all the three parameters, the aerodynamic performance of aircraft will also vary. As you go up and up, density is less, the engine thrust will also reduce. So where we have to use the jet engine, where we have to use the propeller engine, where we have to use the piston engine, this all depend upon the at what height, at what altitude our aircraft is flying. So before we go for the real aircraft designing, every aeronautical engineer has to understand what is the standard atmosphere, where this temperature, pressure and density are varying, in which it is increasing or in which it is decreasing. All these parameters we have to understand before we proceed for any further designing part, or further we are proceeding for this flight mechanics lessons. So researchers conducted experiment with sounding rockets and hot air balloons to study about the variation of temperature with altitude. So in every country, there is some meteorological department. These departments are sending the rockets, sounding rockets, and hot air volume time and again, and they are assessing at what height, what is the variation of the temperature and what is the variation of altitude is measured. Typical pattern of variation of the temperature to altitude is shown in the figure. Here is the figure. So in this figure, if you see the variation of the temperature and altitude, so here this you can see, this is the temperature here, this is the pressure here, and this is the altitude. In kilometer, this altitude is mentioned, and there are, if you see here, number of layers are there. First layer is tropopause, troposphere, then stratosphere, then mesosphere, and then thermosphere. And the line which is separating the two layers, that is the troposphere to stratosphere, is known as a tropopause. From stratosphere to mesosphere is known as a stratopause. From mesosphere to thermosphere, it is called mesopause. So this pause means it is eliminating. This layer is ending here. This layer is ending here. And this layer is ending here. So if we see this diagram, it is very important to understand this diagram. So if you see here, it is Kelvin, 180, 200, 220, 240, 260, 280. Here 280, somewhere 290 Kelvin, it is starting. So means at sea level condition, it is somewhere 289 or 290, it is here. From here, as you go, you increase the height up to 11 kilometer, it is 11 kilometer, your temperature is reducing. So, and also, it is a 1000 hectopascal, it is reaching here somewhere 99 or some 101, okay, like this. So pressure is also reducing and the temperature is also reducing. But as you go above this troposphere, you go to the stratosphere, at some nearly 20 kilometer, the temperature is constant. Temperature is not varying. After that, from here to here, if you see here, near 32 kilometer, it is, slope is less. Temperature is increasing here. But if you go from this 31 to 50 kilometer here, the sharp decrease of the temperature is here. Sharp increase of the temperature is here. So in the troposphere, temperature is decreasing. Pressure is also decreasing. If you see here, up to 21 kilometer, pressure is decreasing, temperature is constant. From here to here, pressure is decreasing, temperature is increasing. From here to here, temperature is increasing, pressure is decreasing. From here to here, again, temperature is decreasing up to mesosphere. And the temperature is very less here. If you see here, it is somewhere 185 Kelvin. It is minus 100 like this. So here it is decreasing. But if you see, pressure is continuously decreasing. So it is very much important that if you want to measure the velocity, air speed, the aircraft speed, or if you want to see the altitude, you cannot use the temperature variation. But if you see here, the pressure is continuously decreasing. As you go up and up and up, the pressure is very, very less. So we can use this pressure as a measurement devices. And in this way, if you see the velocity measurement, your altimeter measurement, all are depend upon the pressure, not by the temperature. So that is the beauty of this plot. Everyone to understand very, very nicely, okay, this plot, and it is called the standard atmosphere plot. So these are the references that Anderson GD, Junior Aircraft Performance and Design, International Edition, McGraw-Hill's first edition, 1999. SL by ME, Aircraft Performance Theory and Practices, AIA Education Series, AIA second edition. These are very good books. You can refer anyone. Any questions, you are welcome to ask. Thank you very much for joining this thing. Also, I request you to be tuned for my next lecture. I will be discussing about instrumentation, measurement of the velocity, measurement of the altitude. This I will be taking in my next lecture. I will also show the real instrument which are used for measuring of the velocity and the measuring of the speed of the aircraft and altitude. So, altimeter and airspeed indicator I will be discussing in my next lecture. Till then, goodbye. Please do like and subscribe this channel. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.